Let's talk about variables. So variables are how we access and store data in memory when our program is running. So if we think about on the right-hand side of the screen, I'm going to call this the computer hardware. And we're going to make some assumptions here, and we're going to say that memory is just a sequence of boxes that we actually don't know a whole lot about. Technically, each of these boxes has some kind of address to it, but we don't know what these address numbers are when we're programming in TypeScript. All right? And so we've got this memory over here, and one of the things that our programs are trying to do is store some values in memory and work with values in memory as we compute different things that we're interested in finding the answers to. So here in this middle section, I'm going to write my code. And the first thing that we need to know when we are trying to access or store some value in memory is we need to declare a variable that will give us access to some memory. So what we'll do is we will say let x be a variable that might hold a number. And once we've declared that it does hold a number, it can only hold a number. And so what this instruction here is doing when the computer reaches this code is it's designating, hey, I'm going to choose out of no particular order, but just because it's free and I know that there's nothing in here yet, I'm going to choose this box that will represent and hold the x variable. So now, later on in our program, whenever we refer to x, the computer is going to know that we are referring to this space in memory. We call this declaration. All right, so I'm going to make another column here for syntax. And this step is called declaration. We are declaring a variable. And when we declare a variable, we use the form let, which indicates this is a declaration of some sort, the variable's name, and that is followed by a colon and then the variable's type. So we know that there are a few types that are primitive to our programming language: number, string, and Boolean. Right? So now that we've declared a variable, we need to store an initial value in it. When we write an assignment statement like this one, x is assigned an initial value of 0. What's happening is, in memory, when the computer reaches this step in our program, and remember it's going to work top to bottom, so it's first going to declare a variable to reserve some space, and now we're saying, all right, assign to x 0. That's going to store a value of 0 in this particular space in memory, and so now we've stored some value in this cubby. X's value is now 0. We call this assignment, right? So let me just make a note here. This is assignment. And the assignment operator is an important one. It's this single equal symbol, right? And that is important because there are other operators in our programming language that also use the equal symbol. When there's only one, it means assignment or takes the value of. And the form here is variable name followed by an equal symbol and then the value that's being assigned to this variable. And what's important to know is that this value always is read on the right hand, is stored on the right hand side of the equal sign and then assigned to the variable on the left. So here we're saying x is assigned a value of 0. We could not write this statement like 0 equal x. This is not transitive in this way. We can't do this. This is very specific syntax that indicates the variable name that we are trying to assign to must come on the left side of the equal symbol. The equal symbol separates that from its value, and then the value that we're trying to store over here is what's going to be stored in the variable. One way to sort of remember this is you can kind of imagine that this is an arrow pointing in this direction. Always, 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 the value on the right is going to be stored in the variable on the left. So now that we've assigned to a variable for the very first time, we can also introduce one other piece of syntax or terminology. This is called initialization. Initialization is the very first time that you assign a value to a variable. So initialization is first assignment of any variable. And what we can take away from this and why this has a special name is because it's important to always initialize or always assign an initial value to every variable. And we do this, and we need to be sure of this, because if we don't, we might run into errors later in our code, assuming that some value had been stored in this space in memory. So that's initialization and assignment. Let's reassign a new value to x. Right? So now that we've declared and initialized, what I'm going to do is I'm going to assign a new value to this variable, because one of the things that's important to know about variables that is different from variables as you may have learned and come to love them in math is that you can reassign new values. What we're saying is not x for the purposes of this program is always going to be equal to 0, but no, we're just storing an initial value of x in our program at this point in our code. So what if we wanted to increase x's value by 1? We could write another assignment statement that is, say, x is assigned x's current value plus 1. And what's going to happen here is we need to remember that the value, the right-hand side of our assignment operator, is always going to need to be evaluated first. And I'm going to make a quick little note that when we access a variable, not as part of an assignment, but as part of an expression that's reading the value of a variable, this is called variable access, or reading a variable. And when we access a variable, what happens is the computer's going to say, all right, well, what is x? What's its current value? And it goes to memory and it looks up its current value. Well, in memory, currently at this point in our program, x is 0. So we take 0 and we would, when the program gets to this point, the computer would say, all right, x is currently 0, so this is going to be 0 plus 1. That gets reassigned to x. So remember, when we see the equal symbol, we know that it's an arrow pointing in this direction. We are assigning 0 plus 1 back to x. So at this point in our code, x is no longer 0, it's going to be 1. We have reassigned a value to x. This exact same line of code could run again. And when this exact same line of code runs again, it's going to have a different result because x's value has changed in memory. So the second time we reach this line in our program, now we're going to look up what is the current value of x at this point. And the current value of x is 1, so this would be substituted with 1 when the computer evaluates it, and then stored back into the x variable, which would cause x's value to change to 2. So we can reassign new values to x. And it's important to remember that variables can be reassigned. When you specify the value as one thing, it doesn't mean that for the entirety of the life of the program, but only until it changes to be something else. So when you're thinking through a program, you need to remember that even though x may be 0 at this point in code, when the computer reaches this line, the value will change, and when the computer reaches this line, the value will change again. Every time you see that a variable is being assigned some value, that's some indication that most likely the variable's value has changed.